Good morning, everybody. My name is Damien Ivory. I run a small telco called Lontel out of Launceston, Tasmania, and we've been dealing with the NBN for well over 5 years now. So today I want to talk about fibre to the node. What is it? What are its issues? And in particular, what are its limitations? So fibre to the node is a technology that allows the telco, in particular NBN actually, to use the existing copper wiring, or at least the last part of it, that is being used for telephone calls and more recently ADSL, and it allows them to put significantly faster speeds over these copper wires. So it's an evolution of the ADSL technology, which has worked very well, but it is very limited in speed. The most you can get out of ADSL is about 20, I think technically it's 24 megabits, but most people, unless you're very close to the exchange, we're probably getting somewhat less than that. So fibre to the node, the way fibre to the node works is that it sends increasingly high frequency signals down copper wires that were never intended for it. Now this creates there are several problems with this. The first is an issue called crosstalk. When you lie two copper cables alongside each other, and don't forget most copper pairs are laid exactly like that, with multiple pairs all running down the same duct, then if you've got a signal going down one copper pair, that signal has a tendency to jump to an alternate pair and create interference. So this is called crosstalk. It's existed even in the voice days. There's situations where you were on a phone call and you could very quietly hear somebody else's phone call. Now they limit this to some extent in the phone era anyway, by twisting the pairs together to limit the amount of interference or the amount of radiation that comes out of each copper pair. However, when you get to really high frequency signals, which is what we're talking about with fibre to the node, this becomes a real issue. So what the node does is a really quite clever piece of technology called vectoring. So what it does is it measures each line, and it sort of sends signals down one and sees what signals turn up on other pairs. And it actually does this in concert with your modem that's sitting on the other end of the line. And they actually talk to each other, compare notes if you like. And so what happens is that the node will then figure out which frequencies are jumping from one pair to another and avoid those frequencies. So that's called vectoring, and it works pretty well. It very much limits your speed though, because every time it finds a sort of frequency black spot and has to avoid it, that obviously is reducing the capacity. So that's how it works. So there are a couple of issues with, well, there are many issues with fibre to the node. It was always meant to be a technology that was a way of just sort of squeezing a little bit extra dollars out of your copper cable. And don't forget, this is using frequencies that copper cable was never designed for. The biggest issue is distance. So the further you get away down that copper cable, the less of that signal makes it to the far end. As it is, the devices are incredibly clever at extracting a very small signal out of the cable when it's gone maybe 400 a kilometer away. But by the time you get to about 400 or 500 meters, the signal really is starting to drop off very, very significantly. So the problem with fibre to the node around distance is you need to put a node within a certain distance of your subscribers. Well, this is great if you're in a relatively high density area, because most of the houses are close together. You can stick a node and probably reach, well, the theoretical limit for a fibre to the node cabinet is some 384 subscribers. But if you start to get to low density areas, there probably aren't that many subscribers within the sort of required distance. And so NBN struggle with a particular issue where in lower density places, it actually would have been cheaper to roll out fibre to the premises. Now, why is that? Because those fibre to the node cabinets are expensive. If you have to put in too many fibre to the node cabinets per, for each subscriber, so in other words, you don't get many subscribers per fibre to the node cabinet, then the cost of implementing fibre to the node really starts to go up. And it actually gets to a point where it is actually cheaper to put in fibre to the premises. Now, this led NBN with a problem, because they couldn't roll out fibre to the premises because that was against the government's mandate. And the other problem is that you get this sort of equality issue, or rather fairness. So it would end up with the people on the outskirts of a town, which typically are low density or lower density, bigger properties, getting fibre to the premises, while those in the middle of town would get fibre to the node. And this would clearly cause some political issues, because typically those people on the outside are generally richer, and there would be the obvious arguments about only the rich people get fibre to the premises and we're stuck in the middle of town and we only get fibre to the node. So what did NBN do? They stuck the edge of towns, and sometimes whole towns, onto fixed wireless. And this is one of the other reasons why fixed wireless is working so poorly, is because frankly there are just too many people on it. There's actually an interesting example down here in Launceston, in a place called Railbia, where they actually did roll out full fibre, and it's pretty rural. It was before, there is one other solution they have to it, and they didn't have this when they rolled out Railbia, but it's to use these things called, well, they're not technically called micronodes, but colloquially they're called micronodes, which essentially is a smaller node, cheaper, and therefore can be rolled out in these lower density areas. The cost pressures aren't so high. So that's the distance problem. The second problem with fibre to the node is that, and this is more a problem for RSPs, is the variable speed. So when I want to go, when a subscriber or a potential customer calls us up and says they want a certain speed connection, if they're on fibre to the premises, we go, yep, right, no worries, here you go, 50 megabits, 100 megabits, or higher, and we can guarantee they will get that because the NBN network will provide the speed that they ordered. Fibre to the node, on the other hand, it's a lottery. In fact, it's been called a fibre to the node lottery. Is what speed will I actually get when I connect? NBN will give us some indication based on the length of the copper about what speeds that people can expect, but these are wildly inaccurate. And this causes RSPs a big issue. The ACCC is very tough on RSPs that sell a product that cannot be delivered, quite rightly, because people want to get what they pay for. So if they pay for an extra speed, they want to know that their line is actually capable of this. So I always think it's somewhat like buying, if you were to go into the supermarket, look at a coffee tin, and it seems to be a certain size. It says 500 grams on the outside, and yet it has a big warning label that says this coffee tin may not be completely full. It may be less than what is actually says on the tin, which would be a crazy state of affairs. But that's sort of what we got with fibre to the node. In-house wiring is a real big issue for fibre to the node. You remember I said these copper cables were never designed for this? Well, nor were people's in-house wiring. They were typically put together for telephone calls, maybe for ADSL. A lot of things were pretty dodgy because it worked and nobody really cared. It's all low voltage, nobody's going to get into trouble. I mean, technically all cabling should be done by licensed cablers, but it often wasn't. So when you get to fibre to the node, which is going to stress the network a lot more than your typical phone calls, that's when you start to get problems. Problems typically are too many sockets, so you really should only have a single socket. And often if you've got multiple sockets, what happens is the signal goes down each leg. The signal strength is divided each time, once it's divided up. and then it goes to the end of the cable, bounces back, and then interferes with the original signal. So it is well worth getting your in-house wiring checked out by a licensed cabler, preferably one who's got a little device that actually can measure the signals on the line. I note that the Labour government, or the Labour Party, is in their election manifesto offering to give NBN a bunch of money to pay to sort out people's internal wiring. And again, you compare that with fibre to the premises, where NBN would lay a completely new cable, in this case of fibre, and it didn't matter what you had there before, because it would just be completely replaced. And this meant that you can very much better guarantee the quality. It's very frustrating as an RSP when people call us up and say, hey, what sort of speeds am I going to get? And frankly, we have to say, no idea, mate. This is what NBN says. Let's connect you up and let's have a look. One of the reasons at Lontel we came up with a free trial period so that we could connect up a service for free and see what speeds people get before they make a final decision about whether they want to use us. When NBN changed to fibre to the node, they claimed it was going to be an awful lot cheaper. It's cheaper for them, there's no question. But is it overall cheaper? Is it cheaper for society? Is it cheaper for the RSPs? And is it cheaper for the end users? Well, clearly not. There are a couple of reasons for this. The first is simply you have to buy a modem, whereas in the past you only had to buy a router. And although there's a lot of confusion about what's the difference between a modem and a router is a very much simpler device than a modem. And so many of you, I'm sure, have been into stores and looked on the various shelves and going, is this what I want or is that what I want? And again, this is all complexity, this is all hassle. I wish that NBN had actually stuck with their original interface, which was an Ethernet port. If you know fibre to the premises or even fixed wireless, come to that, there is an Ethernet port you plug a router in, and that is the point that NBN will guarantee you to the service to. They actually did this on fibre to the curb. You actually do have a device that has an Ethernet port, and I wish they'd done that on fibre to the node, because it would mean that NBN would then be fully responsible for the entire connection and wouldn't be able to do excuses like, you know, the modem's not working properly or the like, because if NBN had supplied the modem, then there wouldn't be this hassle. There's some politics, or some telco politics, let's put it that way, about why they didn't put an NTD in, but I won't go into that. Which brings me along to fault finding, and you know, again, this is all part of the cost of running the service. When a client calls us up saying my connection's dropping out, or I'm not getting very good speed, we then have to go through a process to try and figure out where the problem is. So, could it be their Wi-Fi? Yep, possibly. Could it be their modem? Could it be the in-house wiring? Could it be the wiring in the street? And don't forget, the copper cables that were used are very old. I think one of the Telstra CEOs described them several years ago as 5 minutes to midnight. They're full of gel joints which have corroded cables. There is insulation that has broken down and the like. So it could be in any of those places. So we then have to go through a whole process of figuring out, okay, is it your in-house wiring? And don't forget, we're over the phone to these people. There's no sophisticated test tools that we can figure out what's going on. There are some test tools that NBN will provide, but they only take us so far. Compare that with fibre to the premises, where you've got an optical light. Frankly, if that thing is green, you're pretty much good to go. If that's green, you can plug a laptop directly into the Ethernet port, see if you get an internet connection. If you do, clearly it's something in the customer's premises. If you don't, then maybe it's an NBN fault. The point is that you've got a real certainty about where the issues are, and fault finding is probably the biggest cost when using fibre to the node. The other problem with fibre to the node is during the rollout phase. Now, if you're running a business, you're on ADSL, you might by now already have your phones going over the internet using VoIP technology, even though you're on ADSL. So I come along and say, all right, so you want a new service? So I actually have to effectively disconnect your current service before connecting the new one. This is a problem because if anything goes wrong with that that conversion, you can't go back, and the customer is now down. This internet is probably something they rely on to do their business. They're not going to be very happy about losing their internet connections. Again, fibre to the premises was great because it was rolled out completely alongside what they already had. We'd be able to make sure the new service is fully working before we disconnected the old one. And this changeover problem seems to be very little considered in a lot of the technology decisions. I can see there's a lot of talk about upgrading to fibre to the curb. Again, they haven't considered what are the implications during the changeover. Can we guarantee no downtime or very little downtime? Can we go back if there's some problem? What else have I got on my list? So I think that pretty much covers the issues with fibre to the node. I think the issue is, actually no, there is one other issue that I think needs to be covered, which is the whole overall reliability. We rely on the internet these days. We like to rely on things that are frankly uninteresting. So we rely on the electricity because we don't really care how the electricity got to us. We rely on the roads because we don't really care how the roads were built. We also get frustrated when there's a bit of traffic, but if we're expecting it, we're probably okay with that. Fibre to the node is not reliable, and because of the way it's pushing technology where it was never meant to be, it will always suffer from faults. These are faults that, as an RSP, we have to deal with, which creates cost. NBN have to deal with it, and it creates costs for them. So it was a cheaper technology, but the net result and the cost to us as a country, I don't think is anything like as the cost savings are going to be nothing like as great. And at the end of the day, we're all going to have to replace it soon anyway. All right, that's my end of my segment on fibre to the node. I think it probably is one of the more controversial ones, but give me, put some comments on there if you've got any thoughts to add. Thank you. Bye.